people have probably heard me mention provenance a few times, but what does that mean really in the context of EBRAINS, in the context of a digital research infrastructure like EBRAINS? So one way to think about it is a bit like if you go shopping online and you have an account, then you can see some kind of report of your past activity. So this is my Amazon account, and you can kind of see some of the things I've done over the past few months. And this is something which is obviously extremely useful if you have problems with an order, or you want to repeat an order or cancel it or whatever. But by and large, this is something which is missing in EBRAINS. We don't, except in certain examples, have a record of what users have done on the site. So if they kind of remember, oh, I did something a few months ago, but I can't remember what the result was, it's harder for people to go back and look for it. So there are exceptions. So in the neuromorphic platform, for example, since SGA1, we've had this job manager app, which keeps a record of all the jobs which are run on the neuromorphic platform, with details as to what were the output files from that job, what code was used, what parameters, what was the hardware configuration, and so on. And so this provenance activity is about extending this kind of history of user activity across all of EBRAINS. Also, all EBRAINS services where it makes sense should have a uniform way of keeping track of what people have been doing, for the benefit of the users. So I think obviously we have to respect GDPR and so forth, but for the benefit of the users, it's useful to know what you've been doing on the EBRAINS infrastructure. So a second argument for having is that it enables reproducible research. So anyone who's doing computational research has experienced this kind of problem where you think you've run the same simulation or the same analysis using the same parameters, but the results are different. Or you get your review comments back from the reviewers, and they want you to do some changes for figure 6, but you can't reproduce your original figure 6 because you can't remember which version of the code you used. Or similar stories. If it's not just yourself, but new people come into the lab and want to build on your work, and sometimes just things fail from one day to the next. Now, historically, the way to deal with this situation is that everything that you do in a scientific experiment is carefully noted down in your lab notebook. And this is still a very valuable tool. However, the problem with computational research is that an awful lot of things are buried under the surface. So if the stuff up here on the top of the iceberg above the sea level is, let's say, your Jupyter notebook, and you have a copy of your Jupyter notebook. However, that depends on, the results depend on which versions of NumPy, which versions of Matplotlib, maybe which processor you used. So there's a whole amount of kind of hidden information which generally you don't keep track of, and which nevertheless can cause your work not to be reproducible. And so what we want to do is capture as much of this information below the surface as we can to really ensure that we can reproduce our results. And there's a long list of things that we need to track. So which code did we run? Was it Python? Okay, which version of Python? If we're using, say, NumPy, how was NumPy compiled? And then your own code, which script did you use? Which version of it? Which parameters? What were the input data you used for your calculation? Where were the outputs? Who did it? On what architecture of machines did it run? Did it run on its CSCS or Unix? Which machine? So all of these things could be important to know if you're trying to reproduce your results in future. So we've established that we need to capture as much of this so-called provenance information as possible. And the place for capturing such information in EBRAINS is the knowledge graph. So the knowledge graph is the central storage place for all metadata in EBRAINS. And luckily, the W3C have worked on this problem, which is a very general issue, and they've come up with a standard called Prov. which is based on these three kind of core entities. The idea is that you have some entity, which could be, for example, a model or a data file. You do some activity, you run a simulation, you perform an analysis, and this generates new entities like output data and so on. And of course, these activities are started by an agent, by a person, or by a computer system like Jenkins or something. So you have agents. And so with these three core entities, these three core objects in the Prov data model, plus all of these typed relationships, like an entity can be derived from another entity, an activity, or can be generated by a certain activity. Because this is a semantic graph, the knowledge graph is a semantic graph. Each of these arrows has a different type, if you like. We can use this basic schema to store any activity which is done in EBRAINS. So going a bit more fine-grained, here's an example of how this then maps onto a data analysis activity. And so the activity is an analysis, and this analysis uses a certain script, say a Python script, and it might use a configuration file, which is combined with the script to fully define your analysis. It uses some input data, which could be from again, hopefully coming from the knowledge graph. This again uses a certain computing environment. So you run this in a Jupyter notebook, or you run this on HPC using Unicore, for example. And the computing environment has a hardware part and a software part. These are all entities. And then it generates some results. And so this that lets you kind of capture all of the provenance information about the analysis. Similarly, for a simulation activity, this uses the model, a certain version of the model, and a certain configuration of the simulation. It again runs on a certain computing environment, and it uses certain outputs. So with this basic W3C Prov data model, we can capture all of the metadata for the provenance of data analysis simulation, essentially any activity that you want to do on the EBRAINS platform. There's a question about how can we capture all this information, and there are various ways we can do this. So a very good way is to have a predefined environment. So, for example, the Jupyter notebooks run in a certain Docker container, and that Docker container contains certain versions of the file. So if you know which version of the Docker container you had, then you know which versions of NumPy and so on that you have. However, it's also possible for people to install their own updated versions of NumPy. And so we might prefer to capture the environment at runtime. So at the same time, when you actually run the experiment, we can figure out which version of NumPy we used at the time, and then we know exactly that was definitely the version that we had, and it hasn't changed since we created the environment. Similarly, because we have the Docker image, then if we have that Docker image again in the future, we can just use the same Docker image to run the same simulation in the same environment. There's some disadvantages to that. For example, it's kind of like it's a black box, for example. And so what we want to do as well is also capture the information needed to recreate the environment, like the Docker file, for example. And that lets us build, rerun the same simulation in future, and then perhaps also modify things and check that we get the same results with a slightly modified version of the environment. So the next question is, okay, once we've captured all of this provenance information, what can we do with it? Well, there's many things we can do. So here's an example from the knowledge graph search. If you have a model in the knowledge graph search which used a certain data set, then that link is visible, and you can click on the link and you can go and inspect the data set. And so we can use the provenance information to connect objects in the knowledge graph, and this helps us to better understand how is this model built? It was built by using data from this data set, for example. There's also, you can look into more detail about workflows. You can inspect the workflow provenance in more detail. What I'm showing here is a screenshot of a kind of alpha version in-progress tool for visualizing such data analysis workflows. So this is from a project with the slow wave analysis pipeline, where we start with from a certain recording, and we analyze that ECOG data, and so we kind of extract certain channels from this trial. We can then plot a figure, generate a frame array, perform further filtering, and if you click on each of these boxes, you get more details about exactly which scripts were used to run this analysis, what time it was done. You can see who launched this, and so on. So this is a prototype, but it's online. You can check it out if you wish. So the next topic we should discuss is how do we communicate between the various services, tools, and workflows. So these might be Jupyter notebooks, for example, or it might be some of the graphical tools developed by the brain simulation platforms, or it could be the neurorobotics platform. So one approach is just to directly have each service independently talk to the knowledge graph. So the knowledge graph has APIs which can be used. And this is what was used in our first prototypes. So those of you who have already experimented with Fairgraph for capturing provenance information, that's this solution. The problem with that is that you have to kind of individually authenticate and register each service which wants to talk to the API, and figuring out exactly which service has which permissions gets very complicated. And so we found that rather than try to manage the permissions of every user individually, it makes more sense to build a provenance API in front of the knowledge graph. This can then take care of authentication in a much more flexible, fine-grained manner while still storing its results in the knowledge graph. And so the prototype we have now uses exactly such a provenance API. There is another solution longer term. We would hope that with the lessons we've learned from building this external provenance API, the knowledge graph team itself could provide their own, perhaps more high performance API to make this faster and more integrated. But for the time being, I'm going to demonstrate the kind of intermediate solution where we have an external provenance API, and I now have a demo. Let's see if I can switch to a Jupyter notebook and find the correct one. Okay, so if you go to the no, not that one. I've got too many collabs open. No, sorry about this. I should have planned this more carefully. Okay, so let's open a new tab. Go to the wiki page, and if you go to the there's a collab called something to do with provenance. Here we go, provenance of simulation and data analysis workflows. And here you find in the drive, there is a notebook, an IPython notebook called Simulation Provenance. If you click here, you can then copy it to a new collab. I've already copied it somewhere. So if I go to, so I'm going to run this with my testing account. So here I've copied this notebook into my own collab, and this you can run this through yourself. So essentially, we get the token that we need from the lab environment, and we're going to find and download a model. So it's in fact it's this model. It's just a toy model I've used for demonstration purposes, and it essentially generates a fluctuating memory potential, which occasionally produces spikes. But anyway, so we can search this model's alias here is demo network dynamics. So you can search for models by name, by alias, by ID, whatever. So here we're going to retrieve it from this, in this case, the model catalog API, which Shailesh demonstrated earlier. We're going to retrieve this model based on its alias. And now we have the JSON code, which Shailesh showed you earlier, with all the information about the model. And we're going to download this model into a new directory. So there's a new one for today. And if we run this code, we get the code. It downloads the code. And we now have the simulation script downloaded onto our Jupyter Notebook environment. We can check that we really have the right version, so we can use the cryptographic hash of the file content, and just check it's the same. It is indeed. And now we can run the simulation. So we create some parameters, and we run the simulation. It runs for a short time, and it saves a couple of files containing the membrane potential and the spikes. And there we go. You can see those now appear in our output directory. And now we get to the point where we're going to use the Provenance API. So there are various things we want to store in our simulation report. So a description of what our simulation did, which model did we use, what parameters did we use for our simulation. Then we want to record the output, so these two files. So we have our local path to the file. We have some description of what the file contents are. We store, again, a cryptographic hash of the file contents, so we can be sure if we produce a new file with the same name later on, we can be sure it really is the same file, and it isn't. It's a different file with the same name. We say where it's being stored, in this case on the EBRAINS drive, and we have the content type. We want to know when the simulation was run, so we have timestamp for that. And we have information about the environment. So this is on EBRAINS lab in a Jupyter Notebook, information about the hardware platform that it was running on, and some of the software dependencies. So this script uses Python, NumPy, and Matplotlib, and we can get the versions of those from our local environment. And so we have this this simulation report, which we now can store in the knowledge graph using our API. And you can see that here we have the precise version of Python that was used, and so on. And now if we go again using the model catalog API, we can now post our simulation report to the simulations endpoint. It takes a little while. And just check we get the, yeah, so that worked. And now we have an ID for this new simulation report. And so now we can get a list of all the simulations we've done, or we can retrieve the specific simulation report. So let's go and get the same thing back again, check it gives us the same results. And indeed, we have the same information that we already posted. As I say, we can also in principle, get a list of all of the simulations we've done. Let's do it this way. So let's get a list of all the simulations I've done and saved. So instead of asking for a specific ID, I just get all my simulations. And there we are. Okay, I shouldn't have done that. Live demos. Okay, I don't know why that doesn't work. I guess I possibly haven't even implemented that yet. As I said, it's just a prototype. But you can nevertheless, as I said, that will work soon. By the time you try this, that will be fixed, and you can get a list of all the activity that you've done. And I think, as I showed slightly earlier in the slide, we are currently developing a graphical app to let you visualize these workflows. And so you'll be able to enter for example, this is not an updated version, but you'll be able to enter search for the model which you were interested in, and then see all the simulations that were done with that model. And in fact, we also plan to extend the model catalog app, which Shailesh showed you, to include not only simulations used for validations, but also simulations just for exploratory purposes. So that's the demo. Yeah, so Shailesh has already shown you the model catalog API. So as I say, we're extending this to be more generally useful for model simulation provenance. We're extending the new activity resource API to capture data analysis provenance. And I think the longer term or medium term plan should be to kind of combine these APIs to have a single generic provenance API for all of EBRAINS. And that's where we are right now. Thank you.